Suppose I ask you for sine 30 degrees. What do you get? Half. What about sine 150 degrees? Next, Ben?
Half.
What about sine 390 degrees?
Half.
What about sine negative 300 degrees? That's not right. I want negative, hang on,
330.
180, 210 degrees I want. Or, yeah, 330 would work. What do I get?
Half.
Okay, so then, what is that?
Half.
No.
Two.
Think carefully.
It's 30, 150, 390, negative 210.
It's ambiguous, right? How does your calculator know which one to give? First of all, what does your calculator give you? Ask your calculator. If it's in radians, that's fine. You get pi on 6. It says 30 degrees. What about... How does it choose which angle for negative a half? Which one does it give you?
Negative 30.
Even though there's an infinite number of possible angles, it chose specific ones. Let me phrase exactly the same question in a different way. Here's the sine curve. Oh, that wasn't very good. If I want to draw the inverse of that function, I want to swap the x and the y. I want to flip it. I'm going to have a problem. This is not a function. Because it does not pass the vertical line test.
What's the vertical line test?
Have you forgotten your starter methods already? It's only like 6 months ago. How do I know if a relation is a function? It has to pass the vertical line test.
Never heard of the vertical line test in my life.
You weren't paying attention. Can I draw a vertical line
We did.
that touches more than one point on the curve? If yes, it's not a function. What does that really mean? It means I can't ask you for the value of this function at a particular x value because there's more than one possible answer. So it's not a function. So to define this as a function, we cut out half the curve, most of the curve. We go only that bit, so as to avoid breaking the vertical line test.
And then does it just repeat?
No, that is inverse sine. It has a restricted domain and range. Let me draw it neater for you and more carefully. So, this function is called arcsin. Be careful. Well, arcsin. Some people write it as a sine. They're all the same thing. This function is defined to be this part of that curve. It goes through the origin. You can see if you can tell me what the coordinates of this point and this point are.
1, -1.
That's the horizontal. Yes, you do. Think about the sine curve.
Oh, it'd be pi. I mean, half pi. Negative half pi.
Correct. That's how arcsine is defined. And that's why your calculator chose a negative value when you put in negative a half. It said here, I'm at negative 30. This is the piece that it's defined as.
And what if we put in 360?
Ask it.
And it's just going to be 0.
Ask it. Ask for inverse sine of 360 degrees. Or inverse sine of 2 pi. Tell me what it says.
Non-real.
Uh-huh. It won't give it to you. Because the function is defined only for this domain and range. You can't get a value out of it if you put in a number outside of negative 1 to 1. Not defined.
What if you need that though?
Sorry?
What if you need it?
You don't. You can't do it. Why? Because whenever you ask for sine, you only get a value between negative 1 and 1. So you can't ask for the inverse. It doesn't exist. On this graph, there's no values here. Not in the range, therefore not in the domain of the inverse function. It's just the way it's defined. I could ask you to sketch. Let me ask you first. Do you want to see the arc cos and arc tan graphs first, or do you want to try transformation first?
Transformation.
Any other votes? So I could ask you to, where am I going to fit this? Sketch for me y equals 3 arc sine x minus, do I really want to do that to you?
Yes.
X minus 2 plus 1.
Do we need to know how to sketch it?
It's unclear. Define and use. All it says.
Do you not think
But have you ever
exam?
seen it?
Yeah.
Like
Sorry? I have put them on exams before with the old syllabus, and they've always said that's fine. So I'm assuming that's part of what they mean by use. As I say, this was considered normal. So,
Have you ever seen it on an external?
good question. I haven't looked for it, but I'll go looking.
Wait, when you write an exam for year 12, do they have to approve it?
Yes.
Oh, interesting.
Yes. Your exams this year have not been approved because it's the new syllabus. But normally year 11s do exactly the same exams as year 12s. And they've all been, the correct word is endorsed. All our assessment tasks have to be endorsed before we can give them to students. Okay. Well, there's a transformation, right?
Negative 3 to 1. I mean, negative 3 to 3.
What are we talking about? For this,
Yeah.
what does that change? The x or the y?
The Y.
The Y.
Y is stretched 3 times. So I'm actually going,
3 pi on 2.
would be 3 pi on 2 to negative pi on 2, except I'm adding 1.
Moves it up 1.
You know, this is bad, because I should be adding a multiple of pi to make this easier for myself, right? Let's make it easier for ourselves. Because my y is now an angle. So it was going 3 pi on 2 to negative pi on 2, but now it's going to go 4 pi on 2 to negative 2 pi on 2. So I'm now going from two pi. What's my horizontal shift?
2.
Don't answer for everybody. Give them time to think. Julie, am I going 2 left or 2 right?
2 right.
Okay. So instead of negative 1 to 1, I'm now going 1 to 3. So I'm actually going from here, 1 negative pi. Oh man, where's my middle? Pi on 2 at 2 pi on 2 to here at 3, 2 pi. I've just transformed it. That's the same as the transformation you do for any other graph. I could put negative signs to flip it, blah, 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 blah. But that leads me to the next thing. We are going to define, I should point this out too, this is not 1 over sine. You know x to the minus 2 is 1 over x squared and x to the minus 1 is 1 over x. This is not 1 over sine, it's arcsin. It's just the way it is. Just the way we define it. But that is why some people prefer to write this. You have to be comfortable with all 3 ways of writing this. You will see all of them.